previously, if you're a cloud developer, your day-to-day job looks like you're making some changes on your local machine, you push them to the cloud, deploy the changes, run a few tests, and then you see something breaks and you need to redeploy. This cycle of deployment and testing is slowing developers down. So we have this local emulation where you can now literally run your serverless workloads, your Lambda functions on the local machine, just really speeding up the development cycles.
You are listening to the Kubelist Podcast, a show interviewing project maintainers for open source projects with a focus on CNCF sandbox, incubating, and graduated projects. Hi, I'm Marc Campbell. Together with Benjie DeGroot, we publish the Kubelist newsletter dedicated to Kubernetes and the CNCF ecosystem. I'm the founder and CTO at Replicated, where we enable software vendors such as HashiCorp, Puppet, Harness, and many others to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. Benjie is the co-founder and CEO at Shipyard, where they enable teams of all sizes to build, test, and deploy faster and more reliably via their ephemeral environment management platform. Get started with ephemeral environments at shipyard.build. The Kubelist Podcast is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com. If you're interested in being a guest on this show, or you would like to suggest a project, find us on Twitter at ReadKubelist. Finally, sign up for the Kubelist newsletter and read previous issues at kubelist.com. On this episode of the Kubelist Podcast, Benjie and I were joined by Waldemar Hummer from LocalStack to talk about their project, emulating and mocking AWS cloud infrastructure. Waldemar starts off by explaining the origins of LocalStack at Atlassian and explains what the project does. We spent a lot of time talking about the functionality and how LocalStack works to emulate 50 plus AWS services. There's some really cool stuff here, especially with the EKS emulation. We move on to talk about the V1 release of LocalStack and what's coming up. Waldemar has really been focused on solving this problem for a while now, and he has a lot to share.
All right. As you just heard, we have got Waldemar Hummer with us today to talk about LocalStack. Waldemar is a CTO and co-founder at LocalStack. Very excited to have you on. To get us started, Waldemar, I'd love to hear a little bit about your background, how you got started, kind of where LocalStack came from. But even before where LocalStack came from, just tell us about like the early parts of your career and kind of how you ended up here.
Yeah, sure. It's a pleasure to be here. So Waldemar. I'm the CTO and co-founder of LocalStack. So originally from Vienna, Austria. Started my career in actually working in academia. So I did a PhD in computer science back in the day. I think it was 2014. I defended working on distributed systems, cloud computing, and like the things that were coming up at the time. And then sort of decided not to continue that academia track and started a position at Atlassian. So worked for Atlassian in the data team. Actually relocated to Australia. That was back in I think 2015, 2016. And that was also actually the first lines of code of LocalStack were written at Atlassian. So we had this use case of essentially, developing cloud applications. We wanted to make that more efficient. So we came up with this idea of you could actually emulate part of the AWS APIs on the local machine. And that would enable people to, literally do things like develop their applications offline or while they're commuting on the train. So it kind of started back then as an open source project. And then it was kind of growing over the years. I was kind of the core maintainer for the last couple of years. Was kind of treating it more as a side project, to be honest. So I've been in different roles throughout my career since then. So I worked for IBM in the States for about 2 years, and then also at a large insurance company in Switzerland. And now, basically, the last year or so, we've actually been all in on LocalStack and really built a company and a team around it.
Oh, that's really cool. So this really started off as like a side project. And then you said about a year ago you went all in, and now you're developing it all the way. By the way, we do have Marc here with me as always, and I'm Benjie. I forgot to say that at the beginning there, but always a pleasure to have Marc here. Hi, Marc.
Hey, Benjie.
Okay, so tell us a little bit more real quick. What is LocalStack? Give me a quick pitch. I am a developer at a, let's call it 50-person company, and I'm looking at LocalStack. I do use AWS because I'm one of everybody, but just tell me a little bit about the pitch. What is LocalStack?
Yeah, so LocalStack is essentially, in a nutshell, it is a local cloud emulation platform. So at its core, what we're doing is we're basically taking the AWS APIs and we provide an emulated, mocked version of that on the local machine. And that helps people, actually speed up their development cycles quite dramatically, right? Because whereas previously, if you're a cloud developer, basically your day-to-day job looks like you're making some changes on your local machine, you push them to the cloud, deploy the changes, run a few tests, and then you see something breaks and you need to redeploy. And kind of, this cycle of deployment and testing is becoming quite slow and slowing developers down. So we have this local emulation where you can now literally run like your serverless workloads, your Lambda functions, DynamoDB tables and all that on the local machine, just really, really speeding up the development cycles for cloud developers.
So I have a question for you to kick us off here a little bit more, Waldemar. Like AWS has a lot of services. Like how broad of like an emulation layer are you providing with LocalStack? How many of these services are you able to like recreate?
Yeah, that's a great question. So I think right now we have something in the order of 55 to 60 services that are supported in LocalStack. The services have different degree of parity and sort of depth of support, I would say. So some services are really very well supported. For example, Lambda functions, DynamoDB, and a few other like core services. We also have a few more exotic APIs. I don't know, things like the whole big data suite of Glue and Athena, or even some database systems that you can spin up using LocalStack. And we tend to focus on sort of the core services that AWS provides. And then I think it's currently a suite of 200-ish. And, some of them are really pretty much out of scope, which we're not going to tackle in the foreseeable future. But we definitely put a strong focus on the core services that most people are using on a day-to-day basis.
You mentioned that they're like mocks and emulations for dev environments. Mm-hmm. I'm curious how deep the emulation goes. Like if you look at, DynamoDB or S3, are they actually fully functioning databases, or are they like mock endpoints that you're providing that allow like integration tests to complete?
Yeah, so they're for the most part they're real sort of real endpoints that really mimic and replicate the internal logic of these real APIs. So one example is SQS, the simple queuing service that Amazon provides, and we have a essentially almost 100% complete replica and emulation version of that. We also run what we call parity tests against AWS. So basically, we have a set of integration tests that we first run against AWS, record the requests and responses, and then compare them against sort of running the requests against LocalStack as well. So that gives us pretty high sort of confidence and in terms of achieving a high level of parity with the services.
How do you stay on top of the changes that Amazon's making, right? Like some of the services are relatively mature. So like the API is like the API for S3, right? Like as an example, not changing day to day, but like they're releasing new services. They do like change new functionality. And Amazon, these are proprietary closed source services. They don't necessarily always have, a lot of upfront notification that there's going to be a new version of the API available. So what tools and what methods do you use to stay on top of all that?
Yeah, absolutely. So that's a great question. And generally speaking, so when we look at the evolution of LocalStack as a platform, essentially the code base as it looks today is very different from sort of the early days when we just started emulating a few services here and there. So today we're much more systematic about the approach of how things are tested, how we keep up to speed with the changes of AWS. So one thing that we're now doing increasingly is using the API specifications that the service providers that AWS is publishing. And we work a lot with just auto-generated stubs of the service providers. And that also allows us to basically track the changes of the API specifications and then do things like automatically creating pull requests against our repositories to kind of regenerate the stubs and the service providers. So it's essentially a matter of being very, very much based on what the specifications provide. And this is a very, rich information that we can leverage in terms of all the types, input, output messages and schemas. And when it comes to sort of the semantic inner workings of the service, so here we're really working with these things like parity testing and also leveraging frameworks, for example, like Terraform. So Terraform is actually also something that we use in our own internal testing because they have a very comprehensive test suite for the AWS provider of Terraform. And we actually run that against LocalStack to see, again, like to increase the parity and get like very high fidelity of the services.
Oh, that's cool. So like you're taking these tests that were made to test the actual upstream service and then using them to validate that like your mocks, your emulation layer still conforms to those tests.
Exactly.
Yeah, you mentioned this concept of parity tests. I'm just curious, can you just pragmatically walk me through how that runs and how you do those? Like, because that seems like a really interesting thing.
Yeah, it's actually a great innovation that was coming out of the team in the last couple of months. So there's actually two levels to parity testing. One is that we basically write all our integration tests in a way that the SDK clients, like the clients that make the call to the AWS or the API essentially, they're very easy to exchange. So we can configure clients to run against LocalStack. We can configure all the clients to run against real AWS. What that basically means is we just run the integration tests twice, once against real AWS to make sure that the actual functionality is covered. And then we run the same tests against LocalStack and all the test assertions are in there and hopefully it's going to pass. So that's kind of the more simple version. An extended version of that is what we call snapshot testing, which is really sort of in addition to running it against the two systems, also takes very detailed snapshots of the responses and like records them in a JSON file basically. And then we make detailed comparison of, are we actually returning the right data types? Are all the dates and all the, integer formats in the correct form and so on. And obviously we need to do, a bit of cleaning these snapshot files, things like auto-generated IDs and timestamps need to be, we don't want to match against those, but essentially it gives us a very good mechanism to compare the core parts of the responses and make sure that they have good parity.
That's super cool. And do you guys do that with, what's your CI/CD process look like for building out LocalStack?
Yeah, so we have, it's essentially currently, you'd say it's two monorepos. So we have essentially the open source version, the community version of LocalStack, which is one large monorepo, which is basically the core platform, the core framework that does all the request parsing and has a lot of the core services. And then we have a second repository, which is basically our Pro extensions, which is just a bunch of additional features, additional services that we support and we provide to our Pro users. And so the CI process is basically we have quite elaborate set of integration tests that we run on every basically PR build. We make sure that things that the pipeline is stable, and we try to eliminate flaky tests as much as we can. So we have a pretty stable pipeline at this stage. It runs for about 45 minutes. It has all sorts of parallelization built in. We're actually building as part of the CI process a Docker image. So that's the core artifact or the way how we ship the software. So it's shipped as a Docker image, and we built that for AMD 64 and also ARM 64. So it's a multi-arch Docker build. So also, for example, MacBooks, the M1 processors can use the latest ARM images. And yeah, so this is really typically we just sort of push out the latest tag, which is really essentially the latest commit on master, just gets pushed out as the latest Docker image, and then we have just a semantic versioning for any versions of the commit. We're still at zero verse. We're currently at 0.14.4, I believe, but we actually have some cool plans in the pipeline to release a 1.0 version pretty soon.
Yeah, and then with the 1.0, you're going to the Semver rules change a little bit, and you actually start to really focus on compatibility and ensuring that customers know what to expect when they're upgrading, right?
Yeah, exactly. So this is something we've been putting a lot more emphasis on recently, because we see that a lot of people are, just to give you an idea, so the Docker image of LocalStack, so we keep track of some of the pull stats, is being pulled something around 200,000 times a day. So that's kind of the peak usage of Docker pulls. We just see a lot of dependencies. If things are breaking in LocalStack, then, if we introduce a breaking change, then immediately our issue tracker gets filled up with requests. And so we really try and be more, have more stability and predictability in the changes and the versions that we push out.
I want to go all the way back and talk about the origins of the project. It sounds like a cool project. We're going to dive a lot more into the technology and in what the product does. But you mentioned you were on the data team at Atlassian, and that's where the first lines of code were written and it was created. Let's start there. You said you wanted to be able to have developers. You wanted to be able to write code and build stuff while you were on a train and completely disconnected from the internet.
Yeah, so that's really sort of also a bit like the story that we like to tell, kind of the origin of the project. And the interesting thing is that we get the validation of this use case, even today with a lot of customers who have this exact use case. They just want to be able to iterate quickly locally or even develop offline. But that was really the idea in the early days. We were basically using a set of services like Kinesis streams and Lambda functions and some S3 buckets and a bunch of big data jobs to just crunch some data. Yeah, it was really kind of it had a bit of the cost aspect to it as well, because, for example, if you want to run a very frequent CI build, then, for example, Kinesis shards are paid by the hour. So whenever you trigger a build, it actually you use the shard for the Kinesis stream for maybe a couple of seconds, but you pay for 1 shard hour. At least that was the pricing back in the day. So the cost was one aspect, but then also just the convenience of having like a very reproducible local setup, and the same for like before you push it out into CI and remote. And we really made it work with the local dev setup. We just had to run make install, and it was just basically installing everything for you, and then make test, and just could execute all the tests that were running specifically for these data pipelines that we were building back then, and just all work locally. So that was the early days. It was a very simple version at the very beginning. So we also leveraged some existing tools in the open source space. So there was a few emulators already popping up at the time, and LocalStack essentially built like some glue code in the framework around it to integrate these services. Because one of the things that is bringing a lot of value is the integration between the services. So we already see out there some other projects, they're building some, isolated emulators for individual services. But what we bring to the table is also the integration where you can connect, your SQS to a Lambda function, or you can put a file on S3 and that triggers some other SQS notification. So it's really sort of the integration of the services that make it really powerful.
Yeah, that's a good point. And it's definitely worth chatting about. Like, while all these individual services that AWS offers are powerful by themselves, like, they're rarely used isolated from each other. Like, you have like these backend connections, and they're like, putting a file in S3 triggers like a Lambda function, the one you just described or whatever. And like, having these individual services running in your dev environment doesn't do anything if you can't actually reproduce that behavior.
Yeah, absolutely. And that's really sort of also, I guess, where today, I would say if you look at that, that's more, I can't back this with actual data. So I'm just as I'm thinking about the GitHub issues that are currently being raised, a lot of it is about either entire services missing, or integrations between services. So I think that's definitely something where we put a lot of focus on, and definitely sort of integrations are growing in the AWS ecosystem, right? And it's actually quite amazing what you can already do today. One example is CloudFormation, which is one of these APIs from AWS where you have a declarative specification of your resources, and then it basically creates the stack for you. And one of the concepts there is what they call custom resources. So it's basically in your stack definition, you can actually call a Lambda function that has some custom logic that creates the resource and then returns the result back basically to the CloudFormation engine. And that's one of the integrations we were able to build because we had the CloudFormation engine, we had Lambda support, and we just needed to sort of connect them together. And now we have the full power of custom resources, which are highly used in frameworks like the CDK, for example, the Cloud Development Kit. They're making heavy use of custom resources, and we basically get that essentially for free now, which is nice.
Just to be clear, like these custom resources, that's an AWS feature. We're not talking about custom resources, CRDs in Kubernetes here right now.
Yeah, exactly. So I know that your audience is probably definitely sort of focused on Kubernetes. Yeah, so that's an AWS concept and slightly different, yeah.
But let's talk about Kubernetes. Does LocalStack work on Kubernetes?
Yeah, so we have a Helm chart that's mostly community maintained, so you can actually deploy LocalStack on Kubernetes. There's a few limitations right now. For example, our Lambda execution is pretty much sort of based on Docker. So we assume that we have access to the Docker socket and we can spawn new containers. We're in the process of introducing an abstraction layer that will sort of abstract away the spinning up of containers, and then we can basically just, either use just the Kube APIs to spin up a pod, or even use things like Podman and other container frameworks. So yeah, it definitely deploys in the very basic version, but there's a few caveats. The other interesting thing is that LocalStack can be used to spin up Kubernetes clusters. So we have EKS as an emulation in LocalStack, and for that we actually provide two modes. One is just the mocking mode, which basically just pretends that the resources get created, which is useful if you're developing the control plane for some infrastructure where you're provisioning some clusters. And the actual emulation mode, which really spins up essentially a K3D on the local machine, and then you can deploy your workloads. So that's also supported.
That's super cool. So you can emulate EKS by spinning up K3D. Do you start to be able to play around with things like manage node groups and things like this, so you can actually, like my SRE team can evaluate what what it's going to be like to operate some of that equipment?
Yes, we're definitely venturing in that direction. There are still a few limitations. I mean, we've built a couple of nice integrations. For example, you can, from your EKS cluster, you can spin up pods that pull images from the local ECR registry where you push your images to. We had to do a bit of networking magic to basically make K3D talk to the other Docker container, which is hosting the image registry. So that integration already works nicely. Node groups themselves are something that we're still sort of evaluating and working on. And also think like ingress, for example, works a bit differently than in real AWS. Like anything that has a public endpoint, we obviously need to do some tricks to make that work locally as well with some wildcard domain names and so on. But yeah, so definitely something we'd be super, excited to explore more and get your feedback on.
Okay, hold on. Everyone back up a second here. I want to make sure I understand this because this is cool. And this is definitely cloud native. So if I want to use and emulate my EKS locally, okay, so I'm a developer and I'm using EKS, I'm developing something. I can actually use LocalStack itself to create an EKS Kubernetes cluster locally. So this is super meta here, but I can develop on EKS inside my LocalStack from my local machine, and I've got basically the control plane and everything I want. Is that correct?
Yes, that is spot on. So, in fact, we recently had a chat. We did a webinar with one of the core maintainers of the AWS Terraform modules. So that's a community project that Anton Babenko and a few others are maintaining. And one of the use cases they have a very complex Terraform module for EKS, and they run it through their pipeline, and it takes, I'm not exaggerating, I think at least 15 to 20 minutes, probably just an hour sometimes, to get this module tested. And we're now thinking about getting basically the LocalStack EKS emulation into their CI pipeline, which will dramatically speed up the entire sort of test cycles for the EKS module. But yeah, so spot on what you just said. You can run your EKS workloads with the control plane and all locally.
Okay, this is too cool.
Yeah. I have to say, LocalStack totally makes sense. I completely get the idea. Great. Well, I have a team of engineers that are and we use S3, we use SQS, we use some Amazon services, and we have shared environments that we're deving on. And we don't want to manage actual access keys and secrets, and also the cost. But also just sharing resources is generally hard inside dev environments because somebody wants to upgrade it and it breaks other ones. But the ability to get in and actually emulate EKS in a functioning environment, for folks who are building Kubernetes tools, building tools for developers that rely on Kubernetes, it opens up a path that just really has been really, really difficult to dev on before.
Yeah.
Especially iteration time. I just can't say enough how exciting that is to me, because just iterating on Kubernetes and stuff like that just takes so long. I know you just used that example, the Terraform module, but I just have to come over the top and say that's really super cool.
Yeah. And we're obviously standing on the shoulders of giants here, right? So we're leveraging K3D, which is just a fantastic project, and we just do essentially a lot of the wiring around it and just make sure that it's compatible with the EKS APIs. But also, frankly, there's just a lot of great tooling already in the EKS or in the Kube ecosystem that we can leverage, which is also fantastic.
So, this brings up a bigger question around LocalStack that I want to understand. So each one of these mocks and they're not exactly mocks, they're kind of functional mocks, or I don't know the right way to put them. But let's take a simple example. So at Shipyard, we use RDS. So I want to use and RDS talks to my S3, let's just call it. And I want to use my LocalStack version locally to dev on this stuff. When I'm actually hitting the RDS API, is that just a Postgres? Let's say it's a RDS Postgres. Is that a Postgres container? And for Kinesis or for Redshift or whatever, let's just get a little specific. How are you actually doing this for each one of these cool services? Maybe don't go through all 50 of them, but give me a few highlights here.
Yeah, definitely. So the majority of services are literally running in the main LocalStack container. So we have one Docker container which hosts essentially does all the request processing. We have one, we call it the gateway or the edge port, which is port 4566, and all the requests are going through that port, and we do the route, the parsing and dispatching of the requests, and then it gets forwarded to the services. The services are predominantly written in Python, so there's one Python process running in the container. And then we're using some external processes for different services. So for example, for DynamoDB, we use an external jar file in a JVM, right? So we spin that up, and basically the Python process talks to the JVM process. For things like what you mentioned, Postgres, there's actually different ways we can do this. Either we spin up the Postgres container, or we actually install some Debian packages into the container with just apt. And so if users just want to have one of the major versions that are supported in the package manager, we can use those. And there's a few examples where we spin up external containers. One is, for example, Airflow. So there's the managed Airflow service in AWS. It's one of the more exotic services, but still a couple of our users are using it. And that really spins up just the Airflow Docker container, and we do the wiring with the request forwarding, basically. So there's different ways how the services are deployed, and also they have different mechanisms for things like persistence, for example. We can maybe talk about that in separately, but there's like persistence is something that is also supported for the service, but there's different mechanisms how we do it.
So I have a question for you about all of that. So like what I do on a day-to-day basis, like, my company, we help folks ship on-prem versions of their software, right? Like, and it's just going to run in somebody else's environment. But a lot of vendors will like build into these APIs, and like, there's like a whole different class of problems that aren't just dev environments. And I'm wondering if LocalStack is potentially like an on-prem replacement for like a single tenant, production grade use of some of those APIs, or if you would just not recommend going down that road.
Yeah, that's so we definitely get requests for running LocalStack as a replacement for production workloads, not having to spin up resources in real AWS. We generally tend to not recommend using LocalStack for any productive workloads, simply because it was not designed for these kinds of things, for performance reasons, for security reasons. So it's also frankly a bit of a liability question, because we don't want to be responsible. We're not in the business of hosting production applications of customers. We do know, though, that there is a few installations out there which are hosted in some, for example, internal intranets, which are then used, like shared instances that are then used by all the CI workers, for example, because they can even speed up the CI builds even more if you just, use a pre-installed, pre-deployed LocalStack version that's running somewhere in the infrastructure and it's just shared. We're probably going to move more and more into the area where LocalStack becomes, really stable as a long-running container that you can have, essentially almost like a replacement for production workloads. But currently, we don't really recommend doing it, to be honest.
That's totally fine. So, like, while it may work, it's not the supported workload. I mean, I totally understand that. Like, and hear that. I have a question though. So, like, I'm running it in my dev environment, but my team is like 20 or 30 engineers, and we have a platform team. Is the recommended path for the platform team, for orgs to manage a shared LocalStack installation, and then all the, individual developers or development teams can use it? Or is LocalStack really built so that it's actually like in my namespace, like every developer has their own installation of LocalStack?
Mm. Yeah, so I think that the preferred way to use it is really literally everybody has their own local version that's running in their Docker environments. So we have a few use cases with customers who are essentially developing on remote online IDEs, right? Things like Gitpod or Cloud9 or these online IDEs. And there we have essentially an easy integration where you can spin up the LocalStack Docker container in the context of this remote IDE, for example. So that's also possible. But generally speaking, like, you get the most benefit from using LocalStack if you just literally run it on your local machine, because then you can leverage things like, so we have one feature that we call the Lambda hot swapping or hot reloading, which basically means that you create a Lambda function, and the regular process would be that you upload a zip file that contains the code of your Lambda, and then it gets put into a 3 bucket, and then it gets deployed and started and so on. But what we offer with this hot swapping is you can actually mount a local directory on your local host, on your local machine, into the Lambda container that's running in your Docker. So any change you make to the handler file is immediately reflected in the next invocation of the Lambda, and that allows you to do like even quicker iterations in your dev cycles. And you can leverage most of these benefits really the best if you just run it locally. It's pip install LocalStack start, and it basically starts up. So that's the preferred way.
Got it.
Yeah, I mean, because this is the shill section of Kubelist today, I have to say that we have a few customers that use LocalStack, and actually we do as well at Shipyard. And it's really cool because you get these self-contained external services for every pull request, and it's really, really, really cool. We have not done any of our own testing of our own EKS clusters, but I was just inspired by that, and that might be something that we will be playing with later this evening or tomorrow. But yeah, Marc, I can tell you as a LocalStack user at times, or a peripheral user, if you will, my team uses it. It's really good at just kind of giving you a one-to-one for dev, or one-to-one even for environments, is a really good use case for LocalStack. One thing I will ask a quick question on as a user of LocalStack: am I going to be able to pick and choose which particular services I want? With my Helm chart, or at Shipyard, obviously we use Docker Compose. But one thing I have noticed is that it can be a little bigger than I want it to if I'm just doing, let's say, SQS and S3 and Postgres. And I just wanted to ask, is there plans, or are you already doing this? I don't know about it. How do you break these things up, or is it all kind of just one big image?
Yeah, that's very, very good question. So currently the way to distribute LocalStack is essentially this one monolithic image that has most of the code baked into it. So most of the services are, if they're written in Python, it's just some pip package that's available in the container. And then we also do things like, lazily loading some dependencies. So even though you can actually run your workloads offline, there might be some connectivity required to lazily load some dependencies. But ultimately, it's still just this monolith currently. What we're now doing, and that's also something very excited about, sort of the upcoming release that we're now working towards, is kind of opening up LocalStack as a platform where you can very easily plug in extensions. And like what we envision that over the next couple of weeks and months, even the core AWS services that we provide will essentially become just extensions and plugins in the LocalStack platform. And we're also going to demonstrate how you can build your custom image, for example, that has just the service that you need, for example, SQS, S3, as you mentioned, and you can build like a custom Docker image, like a stripped down version that only has what you need. So we're investing a lot in the installation routine of services, in the whole life cycle. Like, what are the different stages and phases of the service life cycle as it gets loaded, as it sort of starts up, as the health point responds, as we're sort of loading and storing the persistent state. So those things are really helping us to componentize it much more and open it up as a platform that's highly configurable then over time.
I'm really excited to ask you about future plans for opening it up. But before we do that, we're recording this episode about a week or two before V1 goes live, and we're probably going to not get it out for a few weeks after that. Can you just quickly tell us what is the big, what maybe you just told us, but what's going on? Why is it going to V1? What's the big news? Tell us what we can look for and what the big differences are.
Yeah, so we're super excited, and it will be very interesting to, once this episode goes live, to see whether we actually made our timeline for July 13th, which is going to be is the planned release date for the version 1.0 of LocalStack. And essentially what we go out with is a polished version that puts a lot of emphasis on like new features on the one hand side, polishing existing features, and also new documentation, and also some rebranding of our website and the whole corporate branding that comes with it. In terms of the new features that we're providing, so there's a couple of highlights I can briefly talk about. So one is a new version of our Cloud Pods feature. So Cloud Pods, and again, in the Kubernetes context, it's not to be confused with Kubernetes pods. For us, a Cloud Pod is basically a persistence mechanism. It's like a persistent snapshot of your instance that you can take while LocalStack is running. And then you can store this state snapshot to a server, and later on pull down that state and kind of create the exact same copy of the state that you had before. So it's almost like operating with Git objects where you do push and pull. You can now push and pull your Cloud Pods, and this essentially also enables team collaboration where your team members can easily share the application state. So that is one of the features that we're super excited to have, go out with the polished version. The second piece is the extensions framework that I just mentioned. So we're basically demonstrating to the world out there that we are going to open up LocalStack as a platform and sort of venturing out into new territory in addition to AWS, which we've been now focusing on. So we're going to have some demonstrations of additional API emulators that you can easily plug in. So, for example, we're looking to emulate the Stripe API, like a very simplified version of Stripe. And then you can then develop your application to use AWS LocalStack and also the Stripe emulator to develop your apps locally. And we really sort of hope to create some traction also in the community to create these extensions and ultimately, come up with some sort of like a registry of extensions that the people can then exchange and easily share with each other.
Hey, everyone, go check out LocalStack. It hopefully came out, V1, it hopefully came out July 13th. But also, this CloudPod thing, just real quick, is that a memory snapshot or is that just a volume snapshot?
It is basically essentially a memory snapshot. So by default, when you use LocalStack, state is ephemeral environments. I know that Benjie, you're a big proponent of ephemeral environments. So basically you spin up your instance and you tear it down, restart, and you get basically a fresh state, no persistence by default. And CloudPods is now really a mechanism to basically take a snapshot of the current running instance, so that you can then later on sort of inject it back into the instance and restart from the same state.
Wow.
And this, sorry, just one point, this is also quite nice for if you want to do things like preceding some CI environments. Let's assume you have a CI build with some tests and you want to depend on some S3 buckets, some Cognito users, and some Lambda functions. So you can just predefine one of these CloudPods and inject them into the CI environment, and it's like basically up and running within a second and ready and available.
A little while ago, you were talking about a CI process, and you were saying, like, I'm not exaggerating this. The CI process takes 30, 40, 50 minutes sometimes to complete testing end to end. I think it's worth pointing out that, like, that's not unusual really anymore. It's a problem. It's slow. It causes, like, it massively impacts velocity for most engineering teams. But like what you're doing cuts that down tremendously so that I can actually take what you just described with the CloudPods. I can actually have a snapshot in say I have a test that I need to run a migration from point, like A to B. And instead of having to go through the entire process of spinning up point A, I can just be like, boom, here it is, 1 or 2 seconds, and then actually test the part that I care about, which is that migration.
Absolutely. Yeah, totally spot on. So it's both kind of just the ability to iterate quickly with the local APIs, but in addition also having a way to prepare these snapshots, these CloudPods. And that's also something that really, I think, distinguishes us from the real cloud providers, because that's something that I would assume is very hard to achieve, right? Taking an actual snapshot, like with all the entire account information, and then sort of moving that to a different account. There's a few scripts who are doing this. So that these AWS clone scripts, for example, that are just pulling all the resources and recreating them. But then you have things like the identifiers are changing. And so it's very hard to almost impossible to have like a full exact replica of an environment. And we can easily do that because we just, take a snapshot and you can just spin it up again. And that's pretty powerful, we believe.
So we've spent all this time talking about AWS. Are there plans or anything in the product right now to emulate other cloud providers?
So that's great point. So we have been working on an Azure version of LocalStack. So there's been an initial version with some beta program for a few selected users. Frankly, we still have quite some work to do on the AWS side. So we're currently, at least in the next quarter, Q3 of this year, focusing on AWS. But then, so we're now working a lot of like foundational pieces of technology that we can then easily replicate and reuse for the next cloud provider that we're onboarding. So the whole sort of HTTP handling framework, the request response parsing, the state management, the persistence. So we definitely anticipate that sort of, venturing out into the next sort of provider will be a smoother process. Also, from what we've seen, so we spent a lot of time looking at the specifications of the APIs, and you can really see that AWS has grown quite organically over the years with the different services have vastly different types of specifications. And Azure looks a bit more homogeneous. So the services are quite comparable, and they're all based on open API spec. And so it seems like there's an opportunity for us to get that out much quicker than we did for AWS.
Yeah, that makes sense. I mean, you definitely don't want to build LocalStack n number of times from the ground up, where n is the number of cloud providers you support. So there's definitely some reusability, hopefully there.
Exactly. Yeah.
So LocalStack is an open source project. I know that you guys have been heads down for a year making a company out of it. Talk to us just a little bit about how you monetize and how you're going to be sustainable.
Yeah, sure, absolutely. So we're basically a very much open source first driven company. So we have a very strong footprint in the open source. The community version is very powerful, has a lot of services, like the core services that most users are using, and we also contribute a lot to upstream projects that we depend on and we use in our ecosystem. And sort of that's the open source part. And we get a lot of traction from sort of the open source usage. So our GitHub repository is quite popular with something like 40K stars. And then people usually, the upgrade path is usually that people are discovering, maybe some API or some features missing in the community version. And then they can upgrade to Pro, which is kind of our first commercial tier. And we then have actually two more tiers. One is called Team, which is sort of focuses on collaboration features and the cloud pods that I just mentioned before. And then we also have an enterprise feature, or an enterprise tier, which is for more high-touch customers, larger organizations who, for example, need customizations of things like an offline image of LocalStack or special customization with integration with their auth system, SSO, and so on. But yeah, so basically this is what the model currently looks like. Do get a lot of requests for the Pro version and Team and upwards. So it seems like there's definitely a demand for this. And we're also trying to feed more and more of the innovation that we do in the Pro version back into the community version, into the open source, because we really see that over time, we really want to focus on the platform aspect and opening up LocalStack really as the platform that enables integrating a lot of these different extensions that people can actually contribute as well.
That makes sense. The Pro, Team and Enterprise version, focusing on like collaboration features and some of the, custom stuff you've built on top of it. Do you ever differentiate the tiers based on AWS emulated services? Like, for example, would you ever have some services that AWS offers only available in your Pro extensions or Team version, or would you like always keep those in the open source version?
Yeah, so that's actually what's happening already today, that some of the services which we know are a bit more maintenance, and we put quite some effort into maintaining them, things like Athena with this whole big data ecosystem, or also Cognito and a few others. So those services are actually exclusively only available in the Pro version and above. And for community, we have a set of, I think it's by now 30 plus services, which are really sort of the core services that most serverless projects will use for individuals or smaller teams. And then once they need something that's a bit more specialized, they happily usually upgrade to Pro and the tiers about it.
Sounds like some pretty smart PLG growth there for those. I've learned a lot about product-led growth these days. Yeah, right?
Definitely.
But that's really cool to see it working and to see an open core project like LocalStack growing. So you mentioned that they've got, you folks have 40,000 GitHub stars. That's pretty big. Talk to us a little bit about the community. Tell us like kind of where it started and when you started to see kind of it really take off. I mean, 40K stars is one of the bigger projects I know about. Not that stars are the best measurement necessarily, but tell us about the community. Tell us like kind of how it started. And then also, what I'd love to hear is, I know you guys are growing as a company. And it seems like you've maybe recruited some folks from that community. And I think that's really interesting for our listeners to hear about how all that went down. So just talk a little bit about community, how it started and where you started to really see ramp and growth and what you've done to cultivate such a vibrant community.
Yeah, absolutely. So essentially the early days, I think it's all started with some Hacker News posts that we put out there. Hey, we put out this new idea of a local emulator for AWS services and put it on Hacker News, and it just got some initial traction. And I think back in 2017 or so, some folks from AWS actually came across this, and I think Jeff Barr, the chief evangelist from AWS, he put out a tweet on Twitter, and that basically overnight got us, I don't know, like 3-4K stars, new stargazers on the repository. And that really sort of was the point in time when really started to take off quite dramatically. So we got a lot of contributions from the community. So people started creating issues, a lot of, samples, reproducible cases, started, contributing pull requests. We've actually been in touch with a few companies over time that have like entire teams, developer experience teams that are really, whose main purpose is to provide a dev environment that's based on LocalStack to really provide a very smooth experience. So we got a lot of nice contributors there. And we're now also launching some community events, webinars where we actually talk about the usage, what are the best practices, how to use LocalStack. We also want to engage more and more with the community through our Discourse forum page. So we have discuss.localstack.cloud, which we just recently launched, where people can make feature requests, and it helps us prioritize also, which are the features we should be focusing on. So yeah, we're definitely sort of learning a lot from the community. That's our daily bread and butter. Also a fairly active Slack channel with quite a few active members in there. So it's kind of really like that's also very enjoyable about the type of work we do. Is like it's from developers for developers. We understand their problems and pain points quite well, and it's really it's very nice to work with this kind of customers, because you just know what the problems are and how you can help them.
So tell us a little bit about how you've built out the team, though. I'm going to follow up on that one because I think it's really interesting.
Yeah.
Tell us about the people that have joined you and where a few of them, not anything in particular, but it seems like they came from the community itself. Is that correct, or am I misunderstanding?
Definitely partially from the community. So we just sort of realized that a few people who are really active in the repository, we started connecting with them and got a few of them on board in the early days of LocalStack. Now, sort of in the last, let's say, year or so, where we've been a bit more focused on really sort of growing a team of engineers, we've also worked in our own networks and kind of really got a few people on board who are just from our extended networks. But yeah, definitely there's oftentimes people from the community who are just reaching out and interested in making contributions, talk about LocalStack, or even host some webinars, for example, like with Anton Babenko recently with the Terraform modules. So it's really nice, this way of interacting with folks and just also reaching out. It's usually quite a nice conversation opener, because a lot of people are aware of LocalStack, maybe have used it in the past, have, gained some experiences. And then we try to follow up. Hey, have you used it recently? We actually have a team behind it, a company, and, come join us. So yeah, that's definitely quite helpful.
It's really cool to talk to you about this, because it seems like this is kind of like the ideal open source journey that you guys have been on. And it seems like it's really exciting. And this new pluggable stuff that you guys are working on is very exciting to me. I can see, obviously I have a few biases here about running local environments and ephemeral environments, but it's super exciting. Let me ask you this question. If I wanted to start contributing, what's the best place to start? If I wanted to be a contributor, where should I go? Is that, you mentioned there's webinars. Is there like a monthly meeting, or like what's the best way to do this?
Yeah, sure. So we have a newsletter that people can sign up to, and we have a Slack channel where we also put out announcements about upcoming webinars and community events. So I think we hosted the last one a couple of months ago. I believe it was in May, and we're going to host one after the release, basically. So want to establish a cadence of every 2 months or so, getting together with community and just learning from them, having some presentations, use cases, learning how people are actually using LocalStack in different organizations, what the limits are, and also from the contribution aspect. So we've been doing a lot of refactoring of the code base in the last 6 months or so, where we've really prepared it for, more scale, growing the team, and also enabling community contributions in an easier fashion. So it's now much more sort of standardized in terms of how you can plug in a new service provider. So it's a fairly nicely laid out and documented process how you can do that. And especially with the extensions framework that we're now getting in place, I think this will be another boost sort of to make contributions even easier and getting started with LocalStack from a dev perspective, really. So we definitely want to focus more on this experience there.
Okay, so it's an open source project. Talk to us a little bit about the license that it uses and what you guys are doing. And is there any plans to change that? Are you happy with it? Is it a good choice to start with? And just tell us a little about your license choice.
Yeah, sure. So we're using an Apache 2.0 license, so fairly standard and quite popular in the community. It's a commercially friendly license. So, as opposed to some other license models like the GPL or the licenses, which are very restrictive in terms of how you can use the software. We deliberately chose a license that is, very open and also commercially friendly for other people to use LocalStack in different settings. So there's no real restrictions in terms of how it can be used, redistributed and extended. And then we also obviously depend on a few, third-party systems that are also integrated with LocalStack. And we also there obviously make sure that they have a license that complies with what we do. So typically BSD or Apache are kind of the main license we look for. So we don't intend to change that. I think it's been working well. We also, if you've been following the open source projects, like if you look at Elasticsearch, for example, or others who had this issue that, basically their software started being hosted by large cloud providers, and then they had to change the licensing model. I don't think that's necessarily the case for us, because if somebody came along and started a business around hosting LocalStack, they would basically compete with AWS and not with us. So I don't think there's a big concern there. So yeah, we just want to have a very open ecosystem and make sure that we just maximize the adoption of LocalStack. So that's really what we're after. Also as a company, we just want to make sure that it gets out there, and we establish this notion that, local development is possible, because there's still a lot of, let's say, opinion making to be made in the community also, because there's a few people who are a bit skeptical. Is it even possible? What are the limitations and so on? And we demonstrate on a daily basis that it's possible, and it's even like superior in a lot of cases, rather than, using the real cloud environment. And that's really our mission that we want to push forward.
Yeah, and Waldemar, I think, you're right when you talk about like Elastic, or, maybe hit a little bit closer to home with, MinIO, was emulating S3 APIs, and they changed their license. And so a lot of folks start to look at, how do we get some assurance that we're going to be able to use this long term? And there's foundations that exist, right? Apache Foundation. We obviously, this podcast and Benjie and I both work a lot closer with the Kubernetes ecosystem and the CNCF Foundation. Have you ever given any thoughts about making LocalStack an active open source project in one of these foundations, so that, larger organizations who might have been burned by other license changes in the past, not that they're not trusting you, but they don't have to completely just take your word for it. They have the foundation that's actually exists to ensure that the license is going to be consistent. They're going to be able to continue to use it, and there's a ongoing community supported if something happens.
Yeah, that's actually a very good point. So we definitely look into, projects like CNCF and see how we could fit into the landscape. It's very exciting to, essentially, observe what's happening there in the space. And there's so many fantastic projects in under the umbrella of CNCF, and also Apache and others. So far, it's been mostly prioritization problem that we haven't had too much time to look into it. But I think over time, as we are sort of, as the adoption of LocalStack grows, and these requests will be more sort of frequent, coming especially from larger players in the space, I think that's definitely something we'd be considering. One thing I'm vaguely familiar with CNCF, not all the parts of it, but it seems to me that a lot of it is based on essentially cloud agnostic, cross cloud sort of stacks. And currently we're so much tied to AWS that I think we also need to demonstrate this next iteration of opening up the platform for other cloud providers. And I think that would be a great time to think about, under which umbrella could we basically fit the best.
Yeah. I mean, I think that's great. I think that's a good, fair point. And also being super pragmatic about, not shutting the door on it, but saying look, if the demand is there in the future and it becomes a priority, you're willing to entertain that and have that conversation seriously and really consider it. I think that's a great answer.
Absolutely. Yeah.
I just want to meet you at KubeCon. So that's my priority. Just kidding. All right. Well, Waldemar, you had mentioned there's some other cool features coming in V1, and we're not even going to release this until after V1 happens. So maybe give us a hint about a few more. Just give us a few more tidbits of exciting things coming in V1.
Yes, absolutely. So one of the things we've been working on is a new IAM policy enforcement engine. So currently what's happening if you run LocalStack, the default configuration is that it's basically a permit all system. So all the API calls are permitted. You're basically like a root user that can do all the API calls on the emulated APIs. So root, quote unquote, like a root AWS user. Now, what we're now introducing is an actual IAM enforcement layer where we actually check very detailed policies, and you can define your IAM roles, IAM users. Every request is being made under either an assumed role or a user or an actual role. And we have very fine-grained control over sort of enforcing these IAM policies then. Because that's one of the feedbacks that we got from our users was that, hey, this local iterations are great. Sometimes they're hitting a bit of, some barrier once they actually start deploying to the real cloud, because you then get faced with all these, IAM issues essentially, right? Where things you don't have access, your Lambda function cannot access your S3 bucket or other things. And that's something we're really excited about, to also provide an emulation layer. And in addition, we actually also take it from the other side, and we're working on a mechanism to allow you to define record IAM policies based on the API calls that you're making. So that is a bit like observing what the user is the types of requests the users are making, and then kind of looking at the requests and then coming up with policies that are like an exact match for your use case. So we're actually venturing in some of these like security simulation aspects even, right? So you can actually use this and iterate quite quickly with the IAM enforcement engine. The other part, that's a bit more of a technicality, but we're also introducing what we call multi-account. So previously, most of the requests were basically handled under one AWS account, just some synthetic ID. And now you can actually really sort of create new accounts in your LocalStack instance and do like cross-account requests. So that's another quite exciting feature that makes it even more realistic, and like even increases the parity with AWS even further, because you now have these multi-account features basically.
I mean, just that IAM like figure outer to me seems like a product in and of itself. So
figure outer.
Actually, that is the code name of something that we're working on at Shipyard, is the figure outer. So I shouldn't be telling everyone that, but that's fine. But yeah, I love figure outerers. That by itself sounds like an amazing product, just standalone. That's really exciting. And all that stuff is going to be available in the community edition?
So partially community, partially in the pro version. So IAM, as you mentioned, is almost like a separate product that we're going to release for the pro version. A lot of the other things that we talked about, though, are sort of available for the community version. We also introduced a new file system hierarchy. So basically, previously, when you start up LocalStack, you had to configure a bunch of like mount points and other configuration flags, and this is now much simplified. So we basically manage a volume for you where all the persistent state gets stored. So just making it much more like a seamless experience in terms of just getting started without any hassle. And then also what I mentioned before, this parity testing framework, we really roll it out to all the different services that we have to really make sure that we have like the highest parity that we can achieve. And also we're going to publish the actual metrics of that. So you will basically have a website where you can then see, this API with, this service with these API methods has this and this sort of coverage in our tests. So it's like much more detailed overview for our users in terms of what's supported and what we maybe just still working on.
Wow, that's exciting. I haven't dove into LocalStack a little bit personally in a little while, and there's a few things I'm going to be looking at very soon. All right, well, this has been great, Waldemar. Really appreciate the time, and really cool project. Really looking forward to seeing where this goes, and I also look forward to having you back in a year and telling us about all the other clouds and all the other services and all this other emulation and just speeding up our CI pipelines, because that is a real problem. As Marc said, 45 minutes is not an exaggeration. I know multiple companies that have 3-5 hour CI problems. So if you're having that problem, you should check out LocalStack. And in general, just a pretty cool open source project. So thank you so much for coming on. And thank you for contributing to the community and leading it as such a pretty cool project.
Yeah, it's been great. So thanks so much for having me, and also looking forward to reconnecting in a year from now and see what we've achieved in the meantime. So, and check it out, LocalStack, and looking forward to getting your contributions. Thanks for having us here.
That's all we have time for today. If you're interested in being a guest on this show, or if you would like to suggest a topic, head over to Kubelist.com. I'm Marc Campbell, CTO at Replicated, where we enable cloud-native software vendors to operationalize and scale the distribution of their modern on-prem applications to their largest enterprise customers. Check us out at Replicated.com. My co-host is Benjie DeGroot, CEO at Shipyard, where they enable isolated ephemeral environments on every code change for companies of all sizes. Check them out at shipyard.build. This show is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com. And finally, don't forget to sign up for the Kubelist weekly newsletter and read previous issues at kubelist.com.